Hello and welcome back to Geometry with Ms. Farina. Today we're going to talk about area, perimeter, and circumference. Although you may be a little familiar with this, we will step up the level of difficulty, so please make sure you look at all the examples and at times pause and try the examples on your own. Alright, first thing is perimeter. A lot of us know that perimeter is the sum of the measures of all the sides around the figure. So basically when we talk about sum, we're referring to addition. Alright, so anytime we have a figure, to find the perimeter, you basically just add up all of the sides. Okay, now it's key to know that perimeter is measured in just units, because when you look at it, if I have all of these sides measured in inches, when I combine like terms, because I know I add up all the sides, when I combine like terms, my answer becomes, the final answer is going to also be in inches. Okay. Now, what are some things we use perimeter for? We basically look at, putting a fence in a yard. How much fence do we need? Trimming your house. Right, we would find the perimeter of the room, and several other things. Alright, now a square, if you know, a square has 4 congruent sides, so the easiest way to find the perimeter of a square is just multiply the length of one side by 4, and that would give me the perimeter of a square. For a rectangle, you gotta remember, in a rectangle you have your length and your width, right? And with this, we would just do perimeter is 2 times W plus 2 times L. I'll sometimes refer length and width to also base and height. Okay, so since you have two sides, when you add them all up, W plus W gives you 2W, L plus L gives you 2L. Now, area is slightly different to perimeter. Area is the amount of two-dimensional space an object takes up. So if we have our rectangle or square, whatever you decide, it's the amount of space inside. And if you remember, back in junior high, you used to count the number of boxes inside to find the area. And that's because each box was made up of squares, which were 1 unit by 1 unit squares. So you could get away with just counting the boxes. Well, with this, area is measured in units squared. Not units, but units squared. That's key to remember. Perimeter is just your units. Alright, and area is units squared, because when we go to find the area of a rectangle, we would multiply the length and the width. And when you multiply your units, such as inches times inches, you would get inches squared. Now, area is used quite a bit. It's, flooring in a house is an application of area. Sodding a yard, right? How much sod to purchase. When you're painting a room, okay, the amount of paint you need, alright, you would find the square footage of each wall, and the cans could tell you how much paint you need to buy. Okay, so the area of a square, since all 4 sides are congruent, we say the area of a square. The easiest way is to take the length of one side and raise it to the second power. And then the area of a rectangle is just the length times width. And again, you may hear me say base times height at times also. Okay, so let's hit a couple of examples up. When we look at the first one, we notice 4 right angles and these sides are congruent. So we know all the sides are 8 units long. So we go to find the perimeter, right? We would just do 4 times 8, which gives you 32. Since it's measured in inches, it would just be 32 inches. Now the area, since we know that one side is 8, we'd say the area of this square is just 8 to the second power, which would be 64. And because it's area, we know it's going to be inches squared. Sorry, the pen is acting goofy here. Okay, that's pretty easy. Now, here's a rectangle. If this side here is 9, you know the side opposite is 9 also. If this is 11, this is 11. So when we go to find the perimeter, you just do 2 times the length of one side plus 2 times the length of the other. Alright, and that would give you 2 times 9 is 18 plus 22, which is 40, and this would be kilometers. Now the other way you could do it is just do 9 plus 9 plus 11 plus 11, and you would get the same exact answer. Alright, just adding up all the sides. The area, again, is length times width, and that would give you 9 times 11, which is 99 kilometers squared. Okay. Now number 3, when we look at number 3, for the perimeter, right, you're going to pick an area to start. And you know you're just going to walk around and add up every piece of this object. So when we look at it, I start at one place, and I say, okay, the perimeter is going to be from here to here is 5, plus another 5, plus 10 now, plus this here is going to be 15, plus this piece would be 10, then 5, and then you would add another 5 here, and then the last piece, which is right here, 5. Going around the object and finding the area, it's very important to make sure you account for every single side. So we have 5, 10, 20, you have 35, 45, 50, 55, 60 feet long. Okay, so that's how we find the perimeter of that object. To find the area of that object, I think there's 2 ways you can approach it. One, you can find the area of the whole figure and subtract this area here, right? But I think it's sometimes easier just to break it up into a few rectangles. And then I would just find the area of each rectangle, such as this one would be 10 times 5, which gives you 50. Okay, this one here would be 10 times 5, which is 50. Then this one would be basically 5 times this piece here is 5, which would give you 25. So now to find the area, we just add those 3 rectangles up. So you'd get 50 plus 25 plus 50, which is 125, and still feet squared. Okay. Now number 4. All of these little tick marks here tell me all of these are congruent. So if this segment's 2, all of these pieces will be 2 also. So when I go to find the perimeter, right, I'm going to basically take 6. I'm going to add, this has 2 tick marks, that has 2, so that's 6, plus, right, 2, plus another 2, okay, plus another 2. We have this 2, this 2, and finally this last 2. So when you figure out this perimeter, you end up getting 12, 14, 16, 18, 22, 24. And that would be centimeters because it's perimeter. Okay? Now when you go to find the area of this, you can break it up into several different rectangles. I think this might be the easiest. For this one, I would just multiply 2 times 2. That area would be 4. This would be 2 times this piece here. When I look, this piece here is going to be 2 times 4, it's going to give you 8. And this one would be 2 times 6, which is 12. So now the area of that figure would be 12 plus 8 plus 4, which gives you 24. It would be centimeters squared. Okay. Now the sixth example here. When you look at this one, you have this shaded region. Now this is basically like a hole cut out. So what would we do with it? Well, you would take the area of the shaded region, which means the area of the whole region. You would go ahead and you would subtract the area of the unshaded. Okay. So in this case, the area of the shaded region would be, when you look at the whole region, you would do 8 times 12. And when you do 8 times 12, what is that going to give you? 1696. Then you would go ahead and subtract the area of this. The area of this would be 4 times 4. So we would subtract this 16. And that would give us 80 inches squared. So anytime you're looking for an area of a shaded region and you have this hole cut out, you would find the area of everything and then subtract all the holes that are in there. So now, pretty good application here. Your pool is 15 feet wide and 20 feet long with 3-foot wide decks surrounding it. You want to build a fence around the deck. How much fencing will you need? First thing you need to determine is, right, when I'm determining fencing, do I need to find area or perimeter? Well, fencing goes around. It doesn't cover the surface, right? So when we look at it, this tells us we would use perimeter. But here's the thing. If this pool is 20 feet by 15 feet, and you add 3 feet to each side, what you have to understand is this side here would actually be the 15, but you have to add 3 here and 3 on the other side to give you 21 feet. And then when you look at this side here, you have your 20 feet, but you have to add this 3 here and this 3 here, which gives you 26. So the perimeter of fencing you would need would be 21 plus 21 plus 26 plus 26, and that would give you a 42 plus 52, 94 feet of fencing. Okay, so that's pretty much area and perimeter. We have a couple more here. So you are designing a rectangular banner for the front of a museum. The banner will be 4 feet wide and 7 yards high. How many square feet of material do you need? Well, if you look here, what makes this problem difficult is this is in feet, this is in yards, right? And they're asking for the square footage. So not only does the square feet part tell me I'm dealing with area, but my final answer has to be in feet squared. So I have to change 7 yards into feet. Well, if you remember, there's 3 feet is equal to 1 yard. So if I take the number of yards I have and multiply it by the number of feet in each yard, I would get 21 feet. So right away, I know I have this rectangular banner that is 21 feet by, what is it, 4 feet? Ooh, that's not the scale. So we'll change this to 4. We'll change this to 21. And now the area of this would be 21 times 4, which would be 84 feet squared. Alright, so if you are going to purchase material, a lot of times it's in square footage or square yards, so being able to calculate it is key when you go to buy. Okay, next one. If we graph this quadrilateral here and ask us to find the perimeter, okay, I'm going to plot all of these points. So we have -3, -3. it's point K. And we have 1, -3. And we have 1, 4. We have -3, 1. And this is the diagram we get. Now this isn't a perfect rectangle or anything like that, alright, but all it is asking for the perimeter. Well, the vertical and horizontal sides are always the easiest to find by counting the boxes in between the 2 points. So this side would be 4 units long. This side would be, let's see, 1, 2, 3, 4 units long. This side would be 1, 2, 3, 4, 5, 6, 7 units long. But now we have to find this piece here. But you cannot just count that. So what do we have to use? We have to use the distance formula here. So if this ordered pair is at -3, 1, and this ordered pair is at 1, 4, I'm going to use the distance formula to find that. So that would be point M, and then point, this is N, and this is M. So segment NM would be equal to the square root of, we would do 1 minus -3, don't forget to bling bling it, plus, since we started with this 1, since we started with this 1, then we have to start with this 4. So we do 4 minus 1 all squared. So this would give me 4 squared. This would give me 3 squared. So NM would have a length of the square root of 16 plus 9, which is the square root of 25, which ends up being 5 units long. So now that we have all 4 sides of the figure, the perimeter would be very easy. 4 plus 4 plus 7 plus 5, which would give us 8 plus 7 is 15 plus 5 is 20. Alright, since they don't really give you units, it could be measured in inches or whatever, so we would just put units down for that. Okay, now circles. When we look at a circle, alright, a circle is a locus of points that are an equidistant, equidistant from the center. So when we look at a circle, right, you have your center. Then this outer edge is made up of millions and millions and millions of points. When you look at every single point, they will be equidistant from the center. So the distance from the point to any point on the circle is all the same. Now the radius goes from the center to a point on the circle, and that's a symbol for circle. And the diameter goes through the center. I don't know why this is acting like this. Through the center, alright, and endpoints are on the circle. Okay, so when we look at a diameter, I'll start with the radius. Radius starts at the center and goes to a point on the circle. Whereas a diameter will have an endpoint on the circle, go through the center, endpoint on the circle. Well, we know the radius is half the diameter, and the diameter is 2 times the radius. Okay? Now, the area of a circle, it's actually an interesting formula on how it comes up. But the area of a circle, the formula is pi times the radius squared. Okay? And what it's built off of is, if you cut this in pieces and you lay them out like such, right? What happens is the height of your circle ends up being, this kind of mocks what we call a parallelogram. I guess I should do one more to make it right. It mocks a parallelogram where the height of it is the radius, and the base of it would actually be the circumference of the circle, right? Or half the circumference. And when you figure it all out, you end up getting pi r squared to be the formula. Now the circumference of a circle, there's two ways you can do it. Circumference is either diameter times pi, or the circumference is equal to 2 times pi times the radius. Okay, so I know I'm kind of going through this fast, but this is probably a review for you guys. So when I look at the circumference here, what segment is given to me? I have the diameter. The diameter is 12. So the circumference, I feel this formula would work out best, diameter times pi. So when I figure it out, it would be 12 pi. Now I could multiply this out in the calculator, but for right now I prefer all answers to be in terms of pi. So it would be 12 pi. Now the area, to find the area of a circle, it's pi times the radius squared. So I need to find the radius. Well, if the diameter is 12, the radius is going to be half of that. So in this case, the radius would be 6. Right? So, now, if our area is pi times r squared, and this pen is acting goofy tonight, we would go ahead and say it's pi times 6 squared, which would give us 36 pi. Okay? And things keep erasing. So, the letter B here, when we look at it, the circumference, when we look at it's given to us, we're given the radius is 5. So the circumference of this, we would actually use 2 times pi times the radius, which in this case would be 2 times pi times 5, which is 10 pi. And the area is actually even easier in this case because what's nice about it is the area would be just pi times that radius squared. And pi times 5 squared would give you 25 pi. I apologize, things keep disappearing here. Hopefully you're getting them down as you're going along. Okay, so that's circumference and area of a circle. And one more example. It says, find the circumference and area of a circle whose radius has endpoints 0, 0, and 4, 3. So if we plot this, these 2 points in 4, 3, this here would represent the radius. So what you have to picture is some circle, it's probably not going to be the best drawing, coming around like this. Well, in order to find the length of that radius, what we have to use is the distance formula. So if one point is 0, 0, and the other point is 4, 3, right, we're going to say the radius is equal to the square root of, we would do quantity 4 minus 3 all squared plus 3, oh, not 4 minus 3, 4 minus 0 all squared plus 3 minus 0 all squared. So that would give you, come on, a radius of 4 minus 2 all squared would give you 16 plus 3 minus 0 all squared would give you 9, and the radius would be the square root of 25, which is 5. And now if we're looking for the circumference, it's kind of like above. Circumference of this circle would be 2 times pi times 5, which gives you 10 pi. And the area of this circle would be pi times 5 squared, which is 25 pi. Hopefully you enjoyed the lesson. Alright, now hopefully you can work on the homework. Have a good night.